Manager for the ROS-Industrial Consortium Americas. We have 6 different presentations. They're 10 minutes each. So we're going to be running this fairly quickly, just like the lightning talks were. So I'm going to advance here. Here's our quick agenda. I'll give you an overview of the ROS-Industrial Consortium here in North America and some of the projects we're working on. Then we're going to hear from Alex, who's kind of the counterpart in the EU. And then Clay is going to talk about the draft ROS-Industrial roadmap, so we can kind of see where we're headed. And then we have 3 kind of more technical discussions that are about the Connect 2, the new Cartesian path planner for Move It, and finally Ryan is going to show us the demo style that he has in his lab and talk about his wish list for things that he would like to see. So without further ado, Clay, are you able to hear all this?
Sounds good from my end.
Okay. Great. Okay, so this is my summary of our consortium effort. So just to review, Southwest Research is located in San Antonio, Texas. There's about 3,000 engineers on 2 square miles of land and a variety of different engineering disciplines, everything from automotive to kind of sending up satellites, and then also the industrial automation group that I work with. We represent kind of the tip of the spear for the ROS-Industrial community in the Americas. And then you can see on the map there, the world map, the Fraunhofer in Germany. It's representing the consortium and members in the European Union area. If you know of or have ideas for who we should adopt in such a role in Asia, I'm sure we could handle more than one even. Let me know. I'd love to have ideas there. So what is the objective of the consortium? We fulfill a number of different roles. First of all, we're all kind of networking to foster the growth of flexible manufacturing automation through the use of ROS in that type of activity. We provide training. So if you followed our blog at all, we had kind of an introductory training session in March, and then we had more of an advanced training session in May. Some of you I recognize from that, so thank you for coming out. And if you wanted to catch up on what that was, it's all covered on our blog. The community that we maintain includes, of course, the website. There's a fairly deep wiki that documents a lot of the different capabilities on the ROS-Industrial repository. We also have kind of a general mailing list as well as mailing lists for the road mapping and other things like that. If you're interested in that, let me know. You can join the general mailing list for just news and updates on the main page at rosindustrial.org. We do have focused technical projects that are funded by the consortium members, and I'm going to talk to you a little bit about those coming up here. Here's the current status of our membership. I think I showed this in the lightning talk. And our brief history is we've been around as a consortium for about a year and a half. So we launched the repository in 2012 and then started the consortium in 2013. And you can see some of the major events that have happened. And I'll tell you about some of the future events at the end of this presentation. So let's talk about these focused technical projects. This is what we envision as a means to, I guess, improve the capabilities that are within the ROS-Industrial repository. So we have 3 of these that have either completed or that are kind of ongoing. So the first of these is a path planner optimization routine it's a plugin for Move It, or more correctly, a planning request adapter. And the interest there is that if you choose kind of any random Move It planner, you may end up with a longer path plan than it could otherwise take. And so this was involved in kind of creating new kind of minimum joint motion trajectories so that we could have short cycle times. Chris Lewis was instrumentally involved in developing that. So if you'd like to catch up with him on that, he was the same guy who talked about the calibration routines, I guess, just before lunch. The second project is our robotic blending. That is an effort to, without any kind of CAD, to put a part in front of a robot, let the robot scan it, and then plan paths to go and actually blend or sand out different tool marks or chatter marks that are left over from CNC machining. And I've got a video of that. We'll have to flip over to YouTube to see it. I'm going to talk about the third one quickly. So the blending is in milestone 2, is starting now. So we've gotten funding for milestone 1. It's complete. We're moving on to milestone 2, and we'll talk a little bit more during the video. The third one there is CMM-enabled robotic routing. So again, this is inspired by the fact that if you have parts with no CAD, so in this case, these are legacy parts where the drawings are on paper and that hasn't all been transferred to a digital source, they were interested in being able to digitize the part and immediately generate a path plan for the robot. There are literally around 1,000 different parts that kind of have no CAD, and so they're basically digitizing the part while they teach the robot. We're automating that process. That one is in progress, and it should be done in the December timeframe. So let's look at some video. This is a placeholder. We're going to launch YouTube and hold our breath. Okay, so on my end, Clay, we're showing the video on YouTube. I don't know if everyone else out there wants to, they can start their YouTube session. Sorry, the WebEx functionality didn't support video streaming very well. So what's interesting about this is it starts at kind of a macro scanning level. So you first have to identify, where is the blob in the picture, and we're doing that actually. If you saw Chris Lewis's talk, you saw how this was calibrated. So we have a Kinect on the end of a Motoman robot, and his, library was used to identify where the transform from the tool frame of the robot to where the Kinect sensor is. And following that, we're able to then kind of sweep over the area, identify the blob, and then you can see what's happening on the GUI is actually a user interface has been created where you can select blobs that are contiguous and flat, and those blobs can then be segmented, and paths are generated in kind of a, rastering sense, so that mill path can cover that surface. So in milestone 2, we're interested in adding a Keyence laser line scanner. So this is a blue laser line. It'll give us very high fidelity geometry and also surface texture information. It will give us much more accurate path plans. And furthermore, we'll be able to tell whether we've achieved our goal of blending down to a specific roughness. So that's where we are with that. Coming back to web meeting. Okay, so here are our future focused technical projects. So I think I mentioned milestone 2. I don't need to belabor that. There's also there's a robotic CNC milestone 1 project that's starting up, and we are happy to announce that Siemens has gotten behind that. They're kind of the champion for that particular project, and we're interested in anyone who's wanting to explore this more. I can discuss that with you now, or if you'll follow up with me. So the interest here, if you were maybe over at IMTS, you saw some very, very large CNC machines, and when they get outside of kind of a normal tabletop scale, they grow in price quite rapidly. And so particularly in the aerospace industry, it might make sense to use a combination of a stiff robot plus some kind of a high-frequency feedback device to provide a large work volume CNC capability that might compete with the type of capability you get out of a $4 or $5 million monolithic CNC gantry. Our last one there is one inspired by discussions over the course of this weekend, and we're finding that it's common for a number of manufacturers to need to convert their data from an environment, a CAD environment like Pro-E, SolidWorks, CATIA, and translate that into ROS. And right now there's only kind of one wizard that I know of for translating from SolidWorks over into ROS, but even that could use kind of some additional automation to generate things like SRDFs and so on. So if you're interested in that, let me know. We'd love to start an FTP around that particular topic. Okay, some future events. It looks like I'm going over time, so I'm going to stop myself. But here are some exciting things that are coming up, and maybe I'll highlight the very last one there. Come out to San Antonio, Texas in March. We're going to be, that's our annual meeting. Actually, sorry, this will be in, it's Automated Chicago. My apologies, it was in San Antonio last year. So it'll be back up here. It's going to be in parallel with the Automate show. It's early March, and we'll also be doing a training session back up here. So, and And with that, I'm going to move to Alex. Clay, are you able to change us over?
Yep, doing that now.
Thank you. So, hi everyone out there, and hi everyone here. My name is Alex from Fraunhofer IPA, and I want to just give you a short update of what is going on in Europe regarding ROS-Industrial. So, as Paul already said, so we founded the ROS-Industrial Consortium also in Europe, and we are speaking with SWI for I think like a couple of years now regarding the ROS-Industrial initiative, and we decided to also like do a Consortium Europe actually for three reasons. One was actually for legal reasons. Sometimes it's more easy for European companies to contract a European partner. Then the second reason was actually that especially for smaller companies in the industrial world, it's like they don't want to do so much traveling, so we can do like the organize the training and so on directly in Europe. And the third thing maybe is that like the industry in Europe maybe sometimes works a little bit different than the US industry, but still even that these two consortiums, we work very close together, and in the end it's one community. So we put down a slide on the objectives and activities of the consortium in Europe, and we share most of the things with the US consortium. So we want to manage quality standards, we want to offer service to industries like training and so on. We also have the concept of focused technical projects. In addition, when talking to a lot of industrial users or target users of ROS, we felt that there are, besides these application things which the focused technical projects target at, there are also some more general things about ROS that maybe need to get fixed or need to get improved for actual usage in industry. That's where we came up with the concept of strategic projects. So I will come to that more in detail in a second, but that's basically a concept we have only in Europe yet, but we are talking already with SWI if that's maybe should be a global thing. And
so I can confirm that we are in agreement, and we aim to actually amend our kind of contract to include the idea of a strategic project and other kind of terms and conditions, so it's all very parallel.
Yeah. So as I said, the rest is basically almost shared with the US consortium. So we want to manage the quality and standards of ROS for industrial usage, and of course, besides the services, we also want to market ROS in the industrial world. Speaking of, like that, we of course want to market the consortium so we can get more members, but also we want to market it for the community, because also outside of the consortium, of course, there are a lot of developers out there that develop software for industrial robots. And so I want to go a little bit more into detail about the strategic project. So the purpose is basically that when we create a ROS-Industrial roadmap and find certain things in ROS that have to be improved, we actually want to kickstart these developments out of the consortium. So we want to use money from the consortium to actually kickstart developments, which are usually mid or long-term projects. So we expect them to be like 1 or 3 years. And the vision we have is that the money from ROS-Industrial will be part of the project, but of course we also have like contributions from the community. So basically that we have like a shared effort. And since we want to go for that, of course, these strategic projects will be open from the beginning. Also, their concepts or the blueprint basically will be shared with the community, and we also, of course, want to get feedback from the community as well as from the industrial consortium members. And the consortium members, of course, decide then inside of the consortium what project will be funded and what not. So there is an internal review process, and the efforts, at least that come out of the ROS-Industrial consortium, they are basically 100% funded. just to give you an overview what were the recent activities we did. So we did a lot of networking events in the past to like contact with potential consortium members. Of course, we also did trainings, but these trainings, of course, since we didn't have a consortium yet, were just regular trainings. But they are, at least in Europe, we always get a lot of feedback and interest regarding these trainings. And finally, on June 27th this year, we had the kickoff of the consortium. So we have the consortium now in Europe, and so that's basically where we are now. Well, actually, we are later already, but what the current status is. But the schedule which is coming up is basically that we have the ROS-Con meeting here right now, and then in actually next week we will have the first telephone conference, which we have every 3 months, and we will already discuss the first proposals for strategic projects then. Then in December we have the first meeting, the second meeting actually after the kickoff, and we plan to actually spin off the first strategic projects in January next year. So that's basically the overall schedule we aim for. And yeah, so if you're interested in joining the European Consortium, you can contact me or also Ulrich. So I think his name is probably printed on the side. He's managing the Consortium Europe. But you can also contact me and I will forward your interest. So the contracts are ready, so we can discuss them. Also, we have different member types. I don't want to go into much detail here, but if you are interested, just contact me or Uli. So, thank you.
Thank you. Next up, I think we have Clay. Are you there, Clay?
I am now.
Okay.
There's my picture even. We'll start at the end. How about that?
Perfect.
So I'm going to give a quick update on some of the activities that have been going on within the North American Consortium, and in particular our road mapping exercises. So, why build a roadmap? It may be an obvious thing for a consortium to do, but in our case, it's the need is clear. We have now, I guess, 24 or so members, and they're very diverse in terms of their makeup. So we have research institutes, we have manufacturers, we have equipment manufacturers and vendors, and they all have different needs. And so, it's a complex scenario with regards to, how do we conduct ourselves and what are the priorities, what development gets done and when. And so that's really the motivation for the roadmap, is to try to provide some structure to that discussion. So we're taking an approach here that is very sort of end-use oriented. We are starting with use cases, or really trying to define the needs of the end users of the ROS-Industrial toolkit. And then from there, we're developing a suite of technology requirements. So what capabilities are required to enable those use cases? After that, then we go into try to figure out, well, okay, what exists in the ROS community today, and where are the gaps? And then given those, we can put together a set of priorities, which are based on maybe the greatest impact to the membership, and also maybe the most cross-cutting capabilities would bubble up to the top of the priority list. And then lastly, put together funding and implementation plans. So right now, we're in the middle of this process. We're about maybe on the third step, identifying alternatives and gaps. But to take a look back, we developed a set of use cases. There's about 10 of them or so, and you can look at them offline if you're interested. Everything is up on GitHub, and there's a link to the use case document. As you can imagine, because of the diversity of the makeup of the consortium, the use cases are also very wide-ranging. They range from machining topics to welding to human assist, material handling, the optimization FTP that Paul mentioned earlier. So very broad in terms of the application space. But one of the interesting things is that we are starting to see common technology needs even across those varied applications. This is kind of an eye chart, and so you're not going to be able to probably see it all here today, but it is available in the documents online. This is kind of a summarization of all the different technology areas that we've identified. So these are kind of the technology needs that satisfy all of those use cases. You can see there's, I guess, 7 major categories there that range from hardware interfaces. So, for example, developing new low-level drivers to different robot controllers, different sensors, actuators, and so forth. Path planning is a big topic. Almost all of the use cases have requirements in advanced path planning, and so there's a lot of various needs in that space. Mobility is also an interesting topic. There's several members who are interested in how do we make industrial applications mobile, and various others. There's a category there that we call supporting services, which includes things like training and tutorials and developer support tools. So again, pretty wide-ranging, but it's nice that we were able to start to see some kind of trends in that many of the use cases have common needs. So we've identified these use cases and the requirements for each of those, and now we're trying to understand how do we satisfy those requirements. So we're kind of looking across the ROS-Industrial user base and the existing tools and libraries and matching those up against those technology needs. And where there's gaps, we're identifying those, and then the next step will be trying to prioritize how we tackle those gaps. And then finally, we'll publish this all in a single document, and we actually have a working draft of that, which is linked here, and you're welcome to go and see where we're at in that process. Essentially, we're just now starting to identify those gaps and look at alternative technologies. That's it for the summary. I do encourage you to get involved if you're interested. There's a link to the GitHub repository there, which has all of our documents. We also have a monthly phone call, which I don't have linked here, but if you're interested, email me afterwards and I'll send you the information. It is not just exclusive to the consortium. We have involvement across the community, so if you'd like to find out what's going on, please contact me afterwards. Thanks.
Thank you, Clay. See, who's up next here?
Trevin is. Preben, are you there?
I'm here.
Okay. So Preben, I don't think you're able to change the slides yourself, so just tell me when you want to advance.
I'll give it a try. Oh, it worked.
Okay.
Oops. Hi guys, and thank you very much for. I really appreciate the hard work you're doing. It's very encouraging to see how this community is developing. And Alex, especially thank you for taking the effort to try to get a European branch to work out. Really appreciate it. Hope to be able to contribute to significantly in the near future. Basically, what I've been asked to is to share a little bit about the 2 years of experience we have by trying to test and apply the range cameras based on and motivated by the PrimeSense launch. And we've been working for 2 years looking at the applicability of these gaming range cameras, how they could match the barriers of being applied in real industrial applications. And basically, I should have shown some videos here. I think it's available via YouTube. Let's see if it works out for me.
If you have a link, I can launch it.
I have a link. I'll just see if it works out.
Here we go.
Oh, it works. Oh, great. Okay, basically what you see is a very common application that has been desired by food automation for decades. So basically avoiding to have preconditioning of vulnerable food items like bananas, pears, and this kind in the food business. But the same case goes for the protein business and further processed parts. So what we wanted to test out whether it was possible really to without any preconditioning being able to have a bin picking setup like this. And our approach was to try to adopt the PrimeSense. So we got into an NDA with PrimeSense, and we were managing to dive into this technology. And so, of course, some significant limitations that kind of, I think, to the people who's already today involved are pretty obvious. So due to the technology, there are some limitations. Lately, we have been able to start analyzing and validating the improvements of the new Kinect that is in the category of a time-of-flight camera. And to our best judgment on the price level, a very impressive performance on the depth imaging quality. What we are aiming for in our case is that this camera is so accurate and the clouds, the point clouds are so complete that we are working with some data mining that we basically have monitored about 20,000 tons of macro, for instance. And this allows us to do a modeling that is not a stiff or a rigid product, but a stochastic product with a variance that we can model through this huge data set that will allow us to actually weigh products just by observing a partial of the surface. It's of course on the pattern protection, but our aim was to avoid the classical approach of singularizing products on a conveyor and run them through as a conventional built-ware. Raw food gives some additional challenge to a great work people have been doing to be able to do process estimation of rigid prefabricated products with what will you call it, fixed parameters or size or shape factors. Raw food is a little different. When you look at this tray of tomatoes, if you run the YouTube video, you will see it's anyway. Oh, there's sound on this. I'm really sorry. It was not planned to have sound on it, but we just made a first check of do some data mining on tomatoes, and just within 20 minutes and a few thousands of tomatoes, it's possible to do a stochastic model of how tomatoes look like. But you definitely challenged by the PrimeSense. As you see, if you just see the last few half seconds and pause the video, you'll be able to see. Some of you remember back in Cincinnati, we got somebody told us it was shake the Kinect to avoid the destructive interference that this light coding actually has as a major deficit. And if you rerun this video, you will see there's a big difference between how the filtering is needs to reject a significant part of the surfaces simply because the outlier filtering and the fidelity of the patterns are destroyed through this destructive interference. And we started out doing some comparative study. We're definitely interested to hear back from the community what other people have been doing, trying to estimate what is the improvements. The way we see it on the price, the Connect V2 presents some really significant improvements of how the fidelity and the completeness of the point clouds look like. And this is just one slide showing some of the investigations we've been doing. On a calibration front, we are still a little in the dark zone, so we're interested to hear from people that have been working with calibration of the Connect V2. Final, here's two videos. I don't want to waste your time. You can look them up on YouTube, but basically what you can see and what you should look for here is how the necessary filtering to do significant segmentation between colliding products. You see, with the Connect, we have to abandon a significant part of the surface that is within the boundaries of two colliding products. Whereas within the new Connect V2, we are able to preserve a significant higher degree of the surface and also look at the normal. So one of the things we observe here is that once the normal to the surface is dividing a lot from the angle of attack, the Connect and the prime sense doesn't perform well, whereas it's very impressive performance looking at the Connect V2. This is important when you work with products that are heavily colliding. Challenge and requirements. Basically, field of view as off the shelf, we see a necessity to upgrade and get an OEM access to these predefined devices. Basically, it counts within the optics, the range, the quality of the optics, the interference filter qualities. The selected wavelengths is a pretty commodity wavelengths, and it's cheap. It's between 820 and 840 nanometers, but this is not a well-selected wavelengths if you want to operate within specular ambient sunlight. Basically, also, since we work in dynamics that is pretty significant, we need to ensure that we have good sync and full frame shutter. If you need to do complete surface recognition and the completeness of the surface is achieved by having multiple cameras observing the same scene, it's basically a known problem. There are interference problems working with the same wavelengths. So being able to have altering the wavelengths and being able to synchronize or muxing these devices together is important. Also, if you work with robots or conveyors, it's important to be able to triggering or syncing encoders to the image acquisition timing. Finally, I think, at least for us, it's really important to be able to get up to an industrial grade protection and housing. We are working within food, and I think this is one of the most challenging application area. I don't want to waste your time on this. This slide will be available to you. This was just one of the concept designs we were looking at, having more than one illumination sharing the same image capturing sensor. This is, at least in food item relation and the application area, an interesting concept. So the reason why I'm presenting today is because we, as we did in Santa Clara at the Robo Business, trying to open up a discussion with Microsoft. I'm interested to hear whether there is anybody aware of any negotiations or approach towards Microsoft to be able to get an acceptance from these guys that basically, at least from our standpoint, Microsoft Windows license-based driver device is out of the question. So we need these guys to understand that we, to make this device applicable in a professional industrial context, we should be able to gain an access as an OEM license for their core technology and being able to upgrade the peripherals like optics and triggering and so on. If not, we are also, of course, aware of alternatives, time-of-flight camera devices like the PMD. Unfortunately, these devices are not representing the same resolution, spatial resolution and quality. If we look at the more high-end devices like from Hamamatsu and so on, we get into a price level that is overkilling. These devices are mostly designed towards research applications, and for that reason they are kicking themselves out of the context anyway. So I'm interested to hear back from the community, what is your point of view and how important is this for you to be able to see a roadmap getting out of the lab and experimentation phase. Thank you very much.
Yeah.
Okay.
Okay, our next presenter is Risto. Can you hear me, Clay?
Hello.
Good. Is that Risto?
Yes. Hi, everybody. It's Risto. So, everybody hear me good?
Yeah, thank you.
So, my name is Risto Koichev, and today I would like you to present you the Cartesian Path Planner plugin for MoveIt, which was basically developed for the Google Summer of Code project together with the ROS-Industrial. So since I'm a very new face in this community, I would like you to give you a little bit self-introduction of myself. I have a double engineering degree in computer science and electrical engineering. I completed my master's studies at Technical University of Munich, and I've been working 1 year in US and 1 year in Switzerland in different robotic related projects, mainly in the medical robotic field. And now I'm a joint PhD student between the Biorobotics Institute and the Italian Institute of Technology in Pisa, Italy. So basically, what were the project goals? We wanted to develop, So the motivation behind this project was how we can develop a software that is user-friendly for different industrial processes, and how we can develop this software to be more user-friendly and to generate more easily different Cartesian path planners. So as we know, in a lot of industrial processes like painting, welding, user needs to define somehow a Cartesian path, and the current practice is to do it by to teach the robot by showing it. And on the other hand, we have the MoveIt package, which offers a lot of nice libraries for Cartesian path planning, especially collision-free Cartesian path planning, which is essential in a lot of industrial processes. So the project goals were to develop user-friendly Cartesian path planner, to have a simple user interface and user interaction where the user could define a number of waypoints and execute Cartesian path from those waypoints. We wanted to utilize already existing packages like the ROS visualization tools and the MoveIt package. And the main goal was to reduce the user effort while generating the Cartesian path, and we wanted to create a plugin which is very simple to use. So we came up with something like this. This is like the first image when you load the plugin, and the plugin is basically a combination between the Qt widget and the RVis environment, and they both communicate between each other, and all information is simultaneously exchanged between the RVis environment and the Qt widget. So here I have some video, if you can please load it, which gives an overview for this Cartesian path planner. So as you can see, there is a user interaction marker where the user can basically freely move it to the RVIS environment. Once it's clicked, a new waypoint is added, and while you update a new waypoint, you can see if it's inside the inverse kinematic solution of the robot. You get a lot of details in the Qt widget for each waypoint pose. You can change it also from there. You can add a new waypoint from the Qt widget as well as the RVIS environment. And everything is updated simultaneously between if event occurs into the RVIS environment, it's updated in the Qt widget and vice versa. So basically, and also there are a lot of functions that you can have for the waypoints, like the menu. You can remove them. You can also change how you control a certain waypoint. You can load already generated trajectories from a file. You can also save them to a file and load them previously. And you can see in this video this is shown. And here is just a little bit of example, like a use case where we have a robot blending on a surface where we previously have defined a couple of waypoints, and you can see that the robot is basically following these waypoints and executing Cartesian path trajectory. So conclusion, this is more like my personal thoughts, how I see this plugin. I hope that it can be useful for a wide range of users, like from new users of ROS who don't have a lot of experience to more experienced users. I really hope that this plugin will find its real industrial applications, and it can be used not just for visualizing a Cartesian path with already existing packages for Move It, but I believe it can be a very nice tool to test new planners and also maybe further automate the process by, for example, by bringing into the scene external sensor, like for example the Kinect 2, and which can generate certain Cartesian path. Then the user can review this path, correct it, and then execute it. Here are some of the project links. So if you are interested, please take a look. And I would like you to thank everybody from the ROS community who gave their suggestions and help during this process, especially my mentor, Sean Edwards. So thank you very much.
So for all of our presenters who are online, can we give an applause? Thank you. Thank you all for taking time. It's in like 6 or 7 hours later for these presenters, so they were staying up very late to accommodate our schedule. So we're very, very honored to have your time and all of these efforts. Next up is Ryan. Ryan. Switch.
Sure, I'll talk loud.
Okay.
All right. Thanks for having me here. Very grateful, Paul. Name's Ryan Iting. I work for John Deere. I've had a few questions about, well, what exactly does John Deere do, or what do they make? For some of you, we make ag and farm equipment. We also make turf care or lawn tractors. We also do construction equipment. But as a lot of that equipment, we have automation on our equipment. My role as an industrial robot engineer is to try and get more automation that actually makes our equipment. We do a lot of work with Southwest Research, and through some connections there, met up with Paul as came into my new role as an industrial robot engineer, looking at ROS-Industrial. Exactly, what is it? I'm very new to ROS. I've been a weld engineer for about 15 years, spent well over 2,000 or 3,000 hours programming at Teachbended. So as I start to look into this ROS community, I see some amazing things that you guys are doing with robots, a lot of YouTube videos, a lot of information, and I'm just amazed at the amount of time that you can cut out of the things that I've been doing for the last 10 or 15 years. The path planners, the motion capture, and just analyzing, what the environment is and how to react to it. And I see ROS and ROS-Industrial taking that a long ways. So as part of wanting to kind of step into ROS a little bit gradually, work with Southwest Research to install it on our lab robots. We've got a FANUC R2000 with a 165 kilo payload. They put it on YouTube. Good.
Hey, Paul, I think I forgot to make the hyperlink for this video.
Oh, okay.
I'm guessing you can't play it there, right?
Yeah, I can't copy paste either. We're gonna type.
What do you want to do?
Yeah, I'm typing too here.
Okay. Yeah, are you able to copy into the chat window, Clay?
Hold on, I'm gonna play it for everybody. Assuming I can type.
For me to understand exactly, what John Deere is somewhat into our manufacturing areas. So before we go headlong and install ROS on all of our thousands of robots, we need to understand, what's going on with it, how do we use it. We set up this demo cell using ROS Move It and a it. I think we gave it a meter and a half range of motion. Where's the other one?
Still there, Clay?
I am, yeah.
Okay. Is it?
We lose the presentation now?
Oh, we no longer see the video.
Yeah, so I apologize. When you play a video through the normal interface, you can't hear the audio at the same time. So the best thing is probably Heiss sent the link in the chat window, so it's probably easiest to open it there.
Okay. Over there.
We want to still open it, or?
Yeah, we'll advance to it here. Let's see.
So you guys already saw the first half. One of the second half, or the second pick on the robot, was just showing how some of the path planners need to be developed and designed a little bit better. It takes you can imagine with a large robot, any large sweeping motions, you start to get a little scared and nervous. What is it going to hit? But we're trying to develop some confidence and Move It and ROS to make sure that those path planners are not going to take out some tooling or take out a valuable part. After it places it here in the video, you'll see how to get back to the home position, it's going to take a large sweeping and arcing motion. So a lot of the work that the previous presenter was talking about in getting those optimized path planners, that's something we need in our industry. Time is money.
Go back to the slide.
We'll go back to the slide. Just kind of the last slide, just kind of things that we want to see with ROS. We've joined the ROS-Industrial Consortium. We also are looking to apply, as we did with this lab cell, looking farther into what other applications can we do on our shop floor with ROS. We want to get it into production. Paul wants to get it into production too, wants to see it going. I know I'm excited about it. there's some interest after listening to Alex yesterday about the UROC, and can we submit some of those use cases? So I'm going to talk to my counterparts in Europe to see if we can't do that. Some of the wish lists, becoming a new member to ROS, that interface to ROS on the floor needs to be very user-friendly. That's a big push that we've got. And then also being able to interact with our CAD models. We do everything in CAD. If we can make that simpler and that transition better. We need some automation vendors. We've got some of the end users. We've got robot manufacturers. We've got the community here. But we really need some of those system integrators that can help support us and support that ROS development, because when something is broken on my floor, I'm either going to have engineers in-house to support that, or I'm going to have to go out-of-house for that support. And then also ROS for Windows. Most of our computers run Windows. I don't know if that'll ever change. Our IT community loves Windows. So to that, there I am. And if you ever have any questions, feel free to email me. I'd like to talk about ROS-Industrial.
Okay. Well, thank you to our speakers. So I know that